Hi there, kids. Welcome to Chapter 9, Lesson 1. And for this chapter, all of Chapter 9, I really suggest that instead of using our normal focus note or Cornell note page, don't use this guy for this chapter. Instead, use grid paper and make those lines so that it's similar to a Cornell note page. So we'll put our problems and key definitions here, and then our notes will go on this section. And then you'd write the title of the lesson up here. So grab some extra pieces of grid paper for this chapter, and let's get right into Chapter 9, Lesson 1. It is area of a parallelogram. You worked a little bit with parallelograms already in the lab. We do have some vocabulary in this chapter, or in this lesson. The first vocabulary word is a polygon. A polygon is all three of these things have to be true. It's a closed figure, it has straight sides, and no crossing lines. That is a polygon. Okay, now you do not have to copy this page. If you'd like to, you sure could, but I want to show you this. So these are polygons. Closed figure, straight sides, and no crossing lines. Okay, so a polygon has to have at least 3 sides in order to close, but it can have 200 sides as long as they're straight and it's a closed figure and the lines don't cross. These are all non-polygons. This figure does not close, and this figure, all the sides aren't straight. It's got this rounded side to it. And this is not a polygon because the lines cross. Okay, so polygon examples, non-examples, and in our notes we're writing down closed figure, straight sides, no crossing lines. If it meets all 3 of those, you've got yourself a polygon. Okay, next key vocabulary word that we're going to write down is a parallelogram. That is a type of polygon. A parallelogram is actually I'm going to show you a parallelogram by drawing it. And we're going to do quite a bit of drawing in this chapter. So opposite sides of a parallelogram are parallel. And I'm going to draw a line that's 4 boxes across. 1, 2, 3, 4, like that. So I'm going to be drawing a lot of figures this chapter, and listen closely to how I'm directing to draw it, and you'll have the same thing in your notes. So 4 lines, and then go starting at the edge of the line, very corner, go up and over 1, and then make another line that's 4 boxes long. So you got 2 lines that are each 4 boxes, but they're staggered. They look like that. Then I'm going to use my ruler and connect the corners. So there is an example of a parallelogram. Now, on a parallelogram, opposite sides are parallel, like railroad tracks. So here's what that means. Opposite sides, these sides are parallel. I can extend them, they're never going to touch. And these opposite sides are parallel, never going to touch. So I'm going to highlight that and also introduce you to another notation that you see in geometry quite a bit. So these 2 sides are parallel, and these 2 sides are parallel. I should have used a different color. That looks kind of the same. This notation means that these sides are identical. When you see little hash marks like this, 2 hash marks, 2 hash marks, that's in geometry, that tells you that these 2 sides are identical. And I'm going to put a single hash mark here, a single hash mark here. So when you see that notation in geometry, that would be telling you that these sides are the same, and these sides are the same. Those little marks. So a parallelogram is a polygon with opposite sides parallel. 4 sides and opposite sides are parallel. Okay, another type of polygon, and actually a type of parallelogram, is a rhombus. Now, a rhombus is a parallelogram with 4 equal sides. So, let's write that down. A parallelogram with 4 equal sides. These sides are not all equal, okay? This side is definitely not equal to that side. A rhombus is a special type of parallelogram where all the sides are equal. So here's an example of a rhombus. Opposite sides are parallel. This is parallel to that. This side is parallel to this side, and all sides are the same. So I could note that with those little marks. And you also know that shape as a square. So a square is a rhombus. It's also a parallelogram. It's a special parallelogram that is a rhombus. Here's another one. All those sides are equal, and I would indicate that with the little hash mark. This side is parallel to this side. This side is parallel to this side. So this is kind of what most kids would call a diamond shape. So these are an example of a rhombus. It's a parallelogram with 4 equal sides. Here's a parallelogram, but not all sides are equal. I'm not going to write this down, but I could also say that a special type of rhombus is a square, okay? But not all rhombuses are squares. Here's an example of a rhombus that's not a square. What makes a square is that all the angles are also straight corners, 90-degree angles. Here they're not, here they are on that shape. All right, so now let's really get into it and talk about area of a parallelogram. Really what our main focus today. Area of a parallelogram. And I bet you never thought that you were going to talk about bird poop and math, but today that's what we're going to talk about, bird poop. So to start, I'm going to have you make a parallelogram that is, again, 4 units across the bottom. So follow along as I tell you how to draw it. So it's 4 squares along the bottom, 1, 2, 3, 4, like that. And then I want you to go over 2 squares and up 3. So over 2, up 3, and right there at that point, I'm going to make another line that's 4 boxes long, like that. Okay? Then I'm going to connect these corners. Using my ruler, I'm going to connect like that. And now we've got ourselves a parallelogram. Yesterday, or during the lab rather, you explored area of a parallelogram. Today we're making it official. And the formula for area of a parallelogram is this. Area equals base times height. The formula of a parallelogram is area equals base times height. Now, I'm going to simplify this two variables. Just notate A for area, capital A, and B for base. And I'm just going to put the H right next to it. So area equals base times height is the formula. This is the notation we're going to use. Area equals base times height. Two variables right next to each other means they're being multiplied. Now, the base is the bottom. If you imagine setting the parallelogram on the ground, imagine this is the ground right here, that's the bottom. Okay, so the base is the bottom. Base is the bottom, and the height of the parallelogram is, here's where the bird poop comes in, the height is the poop line, and I'll explain that in just a moment. So the base is the bottom, so if I'm looking at this parallelogram, I'm going to highlight the base. That would be this right here. So the base is the bottom of the parallelogram. Now the height is the poop line. So what you need to do is imagine if a bird lands on the top of the parallelogram. Okay, I'm actually going to draw in a little bird here. Here's a bird. And maybe the bird lands on this. The bird could land anywhere on the parallelogram. Actually, let's make that a little darker. So here's the bird. Here's a bird. And what happens? What do birds do? They poop. This bird, if it poops, the poop is going to go straight down. That is the poop line. If this bird landed on the parallelogram and it pooped, it would also go straight down. And I have to imagine if I extended the base over here, it would land right there. That line right there, the poop line, is the height. This line is not the height of the parallelogram. It is a slanted line. The height is the poop line, the line that goes straight down. If a bird landed on the parallelogram and pooped, the poop would go straight down. We're assuming no wind poops. It's not going to fall like this. It's going to go straight down. So that is how you find the height. So I'm going to highlight. Those are examples of heights. And for this parallelogram, let's write that over here. The area equals base times height. The base, this line, is 4 units long, and I'm counting just the line. How many full boxes is this line? 1, 2, 3, 4. So the base is 4. The height is, how many full boxes is the height? 1, 2, 3. So 4 times 3, your height is 12 units squared. That is the area of this parallelogram. Okay, so this is a huge major idea that we're going to be using today. This formula. Area equals base times height. And the base is the bottom, the height is the poop line. So a lot of times you're going to have a parallelogram and it's going to give you a base and it's going to give you a height and you're just going to figure it out. Other times you're going to know the area and you're going to not know what the height is, the poop line, or you might not know the base. So I'm going to write over here, what is the missing height? Okay, there's a way to figure out the missing height of a parallelogram using the formula. All right, so this time I want you to draw a line that's 3 boxes across, or 3 lines, 1, 2, 3, and I want you to come from this corner and go up 2 and over 1. Up 2 over 1 this direction, so that dot right there. And then I'm going to make another line that is 3 units across. Okay, so you've got that. Then I'm going to connect the corners using my ruler. And we've got another parallelogram. Okay, now this time I'm going to write this side is 8 inches. And I'm going to have a bird right here. And if that bird pooped, it would come straight down. So that line is the height. I don't know what that is yet. The area of this parallelogram, I'm going to write on the inside, the area is 40 inches squared. So I know that the area of this parallelogram is 40 inches squared. I know that this side is 8 inches, but I don't know the height, the poop line. I'm going to use the formula and plug in the amounts that I know, and then we're going to solve the formula just like we did in the equation chapter. Always start by writing down the formula. So I'm going to write down the formula right here. The formula for the area of this parallelogram is this. Area equals base times height. And now what I'm going to do is I'm going to write in the amounts that I know. Well, look at this drawing. What do we know? We know the area is 40 inches squared. So instead of that capital A, now I'm going to put in 40. Do I know the base? Remember, the base is the ground. Do I know this side right here, the side that's on the ground? Well, it's not labeled, but actually I do know what it is. It's the same as this. This side is identical to this side. So I'm going to write an 8 right here because I know it's the same as that. If that side is 8 inches, then this side is 8 inches. Okay, those are identical. So I do know the base. The base of this parallelogram is 8 inches. So I'm going to write an 8 right here. I do not know the height. That's actually what I'm trying to find. What is the missing height? I don't know what this is. Doesn't tell me. It's not labeled. So I'm going to leave the h as the height as an h. Well, now I've got an equation with one variable that we know how to solve. Now the step, go back to chapter 7, and let's talk about how to solve this. H is my variable. It's being multiplied by 8. What is the inverse operation of being multiplied by 8? Is divide by 8. So I'm going to divide that side by 8. I have to divide this side by 8 as well. That turns into 1, 8 over 8. So I'm left with h. 40 divided by 8 is 5. So now I know that the height of this parallelogram is 5 inches. I'll label. So today you're going to be practicing how do you find area of a parallelogram when you know the base and you know the height, and you're just going to use this formula. If you're given the base and the height, you just multiply those together to find the area. You might be given an area and the base or the height and be asked to figure out the other missing, either the missing height or the missing base. There's one other thing that I want to remind you that you're going to need today for today's practice, and that is this. How do you go from a fraction, any fraction, to a decimal? We've talked about this many, many times this year. Fraction to a decimal. I want you to be able to use your calculator today, and there are some fractions in some of your practice problems. If you want to use a calculator, a regular old calculator that does not do fractions, here's an example, 5 3/16. If I want to be able to use my calculator for that amount, 5 I can enter in the calculator, but 3/16 I can't. Remember, anytime you have a fraction, it is always the numerator divided by the denominator. Top number divided by the bottom number. So if I type, 3/16 equals 3 divided by 16. Type that in your calculator, and you are going to get 0.1875. So if I have 5 and 3/16, I know that I can calculate the fraction part and figure out that it's the decimal equivalent is 0.1875. So 5 and 3/16, tip this down a little bit, is the same as 5.1875. Now I can type that into my calculator and use a calculator. All right, that does it for lesson 1. Lots of new things on here. All right, I will see you soon for chapter 9, lesson 2.